problem solving, AP style problems. An example of an AP free response question is this one. The function is defined as f of x is equal to x squared minus x minus 6 all divided by 2x squared plus 5x plus 2. First, we're going to have to state the value or values of x for which f is not continuous. And then for part B, state where f is continuous. And then C, evaluate the limit of f of x as x approaches -2 and justify your answer. The next part is to state the equation or equations for vertical asymptotes of the graph of y equals f of x. And the last part that we're going to do is we're going to state the equation or equations for horizontal asymptotes of the graph y equals f of x. Make sure to show all work. Let's get started. To answer our first question, state the values of x for which f is not continuous, we have to first factor, especially the denominator, but why don't we just do both? X squared minus x minus 6 factors to be x plus 2 times x minus 3. And our denominator factors to be x plus 2 times 2x plus 1. So the values of x for which f is not continuous occur at x equals -2 and x equals -1/2. Part B asks us to state where our function f is continuous. Well, we already found in Part A that discontinuities occur at x equals -2 and x equals -1/2. So therefore, we can write where f is continuous, which is the domain of our function, and that's going to occur from -∞ to -2, not including -2, and then again not including -2 to -1/2, still not including it, and then from -1/2 to infinity, and again we're not including that -1/2. Part C asked us to evaluate the limit of f of x as x approaches -2 and to justify our answer. Well, let's first start by taking the limit of f of x. So we're going to do the limit of x squared minus x minus 6 all divided by 2x squared plus 5x plus 2 as x approaches -2. And we factored both the numerator and denominator before to figure out our discontinuities. And then when we factor, we can see that these x plus 2 values cancel out. So it can be simplified to be the limit of x minus 3 divided by the quantity 2x plus 1 as x approaches -2. Well, now we can take -2 and substitute it in for x in both x values of our function. And when we do that, we'll have -2 minus 3, that's -5. And we'll have 2 times -2, -4, plus 1 is -3, and -5 divided by -3 is +5/3. So therefore the limit of f of x as x approaches -2 is 5/3. State the equation or equations for the vertical asymptote or asymptotes of the graph y equals f of x. Well, we know in previous sections of this question that the numerator and denominator can be factored. We had it written as x minus 3 times x plus 2, and then we had 2x plus 1 times x plus 2. And we noticed that the x plus 2 factors canceled out. So we found out from part C that the remaining denominator after simplifying was this 2x plus 1. Therefore, we have a vertical asymptote at x equals -1/2. So that is the only vertical asymptote that we have for this function. State the equation or equations for the horizontal asymptotes of the graph of y equals f of x. Show all work. Well, in order to find the horizontal asymptotes of rational functions, we can find the limit of f of x, or of that function, as x approaches positive infinity and then again negative infinity. And then we would determine what the horizontal asymptote or asymptotes are. So let's start by finding the limit of f of x as x approaches positive infinity. So when we do that, since we have a rational function, we are going to divide all of our terms in both the numerator and denominator by the greatest exponential value in our polynomial, which is x squared. So when we divide all of our terms by x squared, we get a 1 here. We get 1 over x, which would then, as x approaches infinity, it would approach 0. We would get 6 over x squared, and as x approaches infinity, that also approaches 0. We would get 2 plus 5 over x, and as x approaches infinity, that approaches 0. And then we would get 2 over x squared, and as x approaches infinity, 2 over infinity approaches 0. So then that simplifies to be y equals 1/2 as our horizontal asymptote. Let's see what happens when we approach negative infinity. Do we get the same thing, or do we get something different? So again, we divide all of our terms by x squared. And when we do that, we will get 1 minus 0 over 2 plus 0 plus 0. And we would get y equals 1/2 as that horizontal asymptote again. So therefore, we only have one horizontal asymptote at y equals positive 1/2.